Hello my dear students, I am Dr. Jithender Reddy, working as Senior Assistant Professor in the Department of Mathematics and Management Sciences, VNR JYOTHI Institute of Engineering and Technology. In this video, we are going to learn linear differential equations. First, we will discuss what is a linear differential equation, and then we will discuss how to find the integrative factor and how to write the general solution to the given problems. The linear differential equation in y of the form dy by dx plus p of x into y is equal to q of x. We know the simple linear equation in the form of ax plus by is equal to c. Here x4 is a 1, y4 is a 1. That's why we can call this is a linear equation in x and y. Coming to your this differential equation, here y power 1 and dy by dx whole to the power 1, that's why we can say it is a linear differential equation in y, and here does not multiply the y and dy by dx, and here always the derivative coefficient is 1. Here p of x and q of x are continuous and differentiable functions or maybe constants. Then its integrative factor is e to the power integral p of x into dx, and its general solution is y into integrative factor is equal to integral the right hand side function q of x into integrative factor into dx. Just interchange the variables x replaced by y and y replaced by x, then we get the linear differential equation in x, that is this dx by dy plus p of y into x is equal to q of y. Here x4 is 1 and dx by dy whole to the power 1. That's why we can call this is a linear differential equation in x, and its integrative factor is e to the power integral p of y into dy, and its general solution is x into integrative factor is equal to integral right hand side of the function q of y into integrative factor into dy. Now we will discuss a few problems on the linear differential equations. The first problem, solve x into y dash. Y dash is nothing but here dy by dx plus y is equal to log x. Now we are writing in the linear differential equation form. Given differential equation x into y dash means dy by dx plus y is equal to log x. Here the derivative coefficient is 1. Now we are going to divide the x on both sides. Then we get dy by dx plus 1 by x into y is equal to log x divided by x. It is in the form of dy by dx plus p of x into y is equals to q of x. So that here p of x is a y coefficient, that is 1 by x, and the q of x is the right hand side function, that is this one log x by x. Now we are writing its integrative factor. The integrative factor formula is e to the power integral p of x into dx, then this is equal to e to the power integral p of x is 1 by x into dx. Then this is equals to the, we can write e to the power integration of 1 by x is a log x, e and the log is a cancel there, then we can get x. The integrating factor of this differential equation is x. Now we are writing the general solution. We know the general solution of the linear differential equation y into integrative factor is equals to integral the right hand side of the function q of x into integrative factor into dx plus c. This is the general solution of this linear differential equation. Here y is a dependent variable, so that here the dependent variable into independent y into integrative factor is equal to integral q of x into integrative factor dx plus c. Now we have to substitute what is the integrative factor of this differential equation x. We have to substitute here. Then that implies y into integrative factor is x is equals to integral q of x, that means the right hand side function log x by x into the integrative factor is x into dx plus c. Here this x is a cancel, then we can write integral log x into dx plus c. We know what is the integration of the log x. Integration of log x formula is x times of log x minus 1. So that integration of log x is x times of the log x minus 1 plus c. This is a general solution of the given differential equation. Let's go to the second example. Solve 1 plus y square into dx plus x minus tan inverse y into dy. Here y power is 2, x power is 1, so that we can able to write this equation as linear differential equation in x. We cannot write in y since y power is 2 there. Now we are going to rewrite this equation as one plus y square into dx. This dy we are writing here, dx divided by dy plus x minus tan inverse y is equals to 0. Then that implies 1 plus y square into dx by dy plus x is equals to tan inverse y. In the linear differential equation, the derivative coefficient always unity. That's why we are going to divide 1 plus y square on both sides. Then we can write dx by dy plus 1 divided by 1 plus y square into x is equals to tan inverse y. Here x power is 1, its derivative power is 1, so that we can say it is a linear differential equation. It is a linear differential equation in x, that is of the form dx by dy plus p of y into x is equals to q of y. So that here p of y is the x coefficient, that is this 1 divided by 1 plus y square, and q of y is tan inverse y divided by 1 plus y square. Q of y is equals to tan inverse y divided by 1 plus y square. Now we are going to find its integrative factor, since the integrative factor formula is e to the power integral p of y into dy. In the previous example, there we wrote the integrative factor is e power integral p of x into dx there. Since there the differential equation in y coming to here, this is a linear differential equation in x, coming to x, the integrative factor is equal to e to the power integral p of y into dy. So that this is equals to e to the power integral p of y is 1 divided by 1 plus y square into dy. Integration of 1 divided by 1 plus y square is tan inverse y e to the power tan inverse y. This is a required integrative factor. Now we are going to write the general solution to this differential equation. This is a linear differential equation x, so that its general solution is x into integrative factor is equals to integral the right hand side of the function q of y into integrative factor into dy plus some constant c. Then that implies x into, here what is the integrative factor? E to the power tan inverse y, e to the power tan inverse y is equals to integral q of y. What is the q of y? Tan inverse y divided by 1 plus y square, tan inverse y divided by 1 plus y square into integrative factor is e to the power tan inverse y into dy plus some constant c. Directly we cannot evaluate this integral. We can able to evaluate this integral by substitution method. We are going to substitute tan inverse y is equals to z. Then derivative of tan inverse y is 1 divided by 1 plus y square into dy is equals to dz. Now we have to substitute this one in this expression. Then we can get x into e to the power tan inverse y is equals to integral 1 divided by 1 plus y square into dy, that is 1 divided by 1 plus y square into dy is this, so that replace we are writing this d z, tan inverse y replace z, e to the power z, z into e power z into dz. We can evaluate this one according to the integral by parts. We know the integral by parts formula. Integration of u v dx is equals to u into integral v dx minus integral u dash into integral v dx whole into dx plus c. This is a integral by formula, integral by parts formula. Here u is a z, u is a z, v is a exponential function. Then is equals to, here first we have to write the u as it is, that is a z, into integration of v, integration for this, that is e to the power z into dz, minus integral u dash means derivative of z, that is a 1, into integration of e power z, that is same as e to the power z into dz plus some constant c. Then that implies x into e to the power tan inverse y is equals to z into integration of e power z is same as the e to the power z minus integration of e power z is same as the e power z plus some constant c. Then that implies x into e to the power tan inverse y is equals to z minus 1. Here e power z is a common, that's why we are writing z minus 1 into e power z plus some constant c. Since z is tan inverse y, so that z replace we have to write the tan inverse y, x into e to the power tan inverse y is equals to z is tan inverse y minus 1 into e to the power tan inverse y plus some constant c. It is a required general solution to the given problem. I gave few worksheet problems. Dear students, you have to practice them. Then you can able to answers to the another questions. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.